Now let's talk about how to make ethers. You have actually learned most of these reactions. The first one is condensation of alcohols. This is actually an acid-catalyzed dehydration of alcohols. It's an intermolecular dehydration. So some of you probably remember that we talk about acid-catalyzed dehydration of alcohols to give alkenes, and that's the intramolecular dehydration. The temperature will make a difference in the intramolecular dehydration. To make alkenes, we want relatively high temperature, 170 degrees Celsius. At a little lower temperature, 140 degrees Celsius, intermolecular dehydration will take place. Two alcohol molecules will condense together, and one small molecule water is removed to give ether as the final product. So here's an example. 2 ethanol condensed together in sulfuric acid at 140 degrees Celsius. That's the way to make the diethyl ether. The mechanism is very straightforward. The first step is the protonation. As I said, acidic condition alcohol. The first step is always protonation on the alcohol oxygen. The second step, the second equivalent of alcohol, will serve as the nucleophile to attack on the carbon attached to the protonated oxygen, and the water is the leaving group. So this step will make the protonated ether. It makes a new oxygen carbon bond. And the last step, deprotonation, to give the final product. Okay, so it should be very straightforward. And the key step is the nucleophilic substitution step, when the second alcohol attacks on the carbon with the protonated oxygen. SN2 reaction. Alright? And because we want SN2 reaction here, so there's one requirement for the alcohol. We want primary alcohols. If it's a tertiary alcohol, the reaction won't work as expected. Secondary, not good either, because elimination may compete. So this method to make ethers, the two alkyl groups would be primary ideally. The second way to make ether is called acid-catalyzed addition of alcohol to alkenes. That's the same addition reactions that you have learned in chapter 6. So here's one example. Double bond with acid, and ethanol is added. So OCH3 and H will be added across the CC double bond to make an ether. The mechanism, straightforward. First step is the addition of the proton to the double bond. It gives a stable carbocation, and this is why the reaction follows the Markov-Nikov's rule. We want the more stable carbocation. Second step, methanol serves as a nucleophile to combine with the carbocation to give a protonated ether. And the last step, deprotonation, final product ether, which is the Markov-Nikov product. Alright, The third method to make ethers is the solvolysis of tertiary alkyl halide in alcohol. So tertiary alkyl halide reacting with, for example, methanol in this case. Methanol serves as both the solvent and the nucleophile, so it will replace the Cl on the tertiary carbon. This is the SN1 reaction. It goes through a tertiary carbocation intermediate. The last method we will talk about here is relatively new to you, but you've actually seen the reaction before. It's called Williamson ether synthesis. In Williamson ether synthesis, we want an alkoxide, the conjugate base of the alcohol, to react with an alkyl halide. Primary alkyl halide is needed. And the alkoxide will serve as a nucleophile to replace the halide. So a new carbon-oxygen bond is made, and ether is the final product. And this is a very typical SN2 reaction. And that's the reason why we need a primary alkyl halide, because alkoxide is a strong base. Under this condition, elimination may compete. So a tertiary, secondary alkyl halide won't work, only primary alkyl halide. So in this next example, you've actually see it in one of the problems that we posted on Blackboard for substitution elimination reaction, right? We prepare that phenoxide ion by reacting phenol with sodium hydroxide, right? This reaction actually makes the nucleophile for the SN2 reaction. Anyway, for Williamson ether synthesis, we are actually using alcohols as the starting material to make the alkoxide as well as the alkyl halide. How do we make alkoxide from alcohol? With sodium ion, right? Sodium will replace the hydrogen. And how do we make alkyl halide from the alcohol? With HX, hydrogen halide, or thionyl chloride to make chlorides, or phosphorus tribromide to make alkyl bromides. So I hope all these reactions that you have learned previously will come back in your mind, and you can use these reactions as needed.